Alright, welcome to Chemical Names and Formulas Part 2. In this part of the online lecture, we'll be talking about the names and formulas for covalent compounds. Covalent compounds are a lot more flexible in terms of how the elements can combine than ionic ones are. And so what that results in is all sorts of different combinations for any two given elements. And so to reflect this, they've actually had to use a slightly different naming system than the ionic compounds. So the covalent naming system is based around a prefix system. And word skills here, prefix is a word part that goes on the front of a word. So, and what they've done is they use prefixes for numbers, amounts. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, and we can even go to 10 if we want. And so the prefixes that the covalent naming system uses are mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. So the covalent system uses these prefixes. And it wouldn't be a bad idea maybe to write these prefixes down somewhere so that you have access to them when you're taking a quiz, a mastery quiz, or a test or something like that. Maybe throw them in your planner somewhere. It would be a pretty good idea. Probably by the end of the course, you'll have a pretty good handle on most of these as it is, if you don't already remember a lot of them because of geometry anyway. So let's get into names and formulas. Covalent compounds, it's more difficult to come up with the formula from just two elements. So usually with the covalent stuff, you're going to be given one or the other, either the name or the formula. So let's start with a formula first. And then I'll show you how if you have the formula, you come up with a name using these prefixes. And then we can do one going from the name to the formula. And then that'll be the end of this lecture. So let's start with a formula like, oh, I don't know, let's just choose N2O3. So N is nitrogen and O is oxygen, and according to this formula we have 2 nitrogens and 3 oxygens. So here's how all of this works. There's a set of rules for how you use these prefixes. The first element will only get a prefix if there's more than one. So basically that rule is you never use mono on the first element. Well, we have 2 nitrogens in this case, so we don't have to worry about that too much, but you never use mono on the first element. So we have 2 nitrogens, and the prefix for 2 is di. So the first part of this name is going to be dinitrogen. We just combine the correct prefix for the number that we have. So we have 2 nitrogens, and the prefix for 2 is di, and we combine that with the name of the element that is the first element. So we have dinitrogen, that's the first one. And now the second element is oxygen. And one thing that the covalent names have in common with the ionic names is that the second element always has to end in "ide." So if you remember from part 1, oxygen, right? You drop the "igen" and it becomes oxide, right? And we have 3 oxygens, so we've got trioxide. Right? So we've got 3, and the prefix for 3 is tri. So we take, it's oxygen, you have to drop it's the second one, it's the last one, so you drop the end of the name and you add ide. So oxygen becomes oxide, and then we have 3, so we have to use the prefix for 3, which is tri. So trioxide. So the name of N2O3 is dinitrogen trioxide. Let's look at another one. Let's say you had kind of a familiar compound, CO2, right? Remember that first rule that I mentioned? The first element never ever gets the prefix mono. And I'm just going to go ahead and write it, never on first element. So we never use mono on the first element. So the first element here is carbon, and there's one of them, but it's not monocarbon. It's just carbon. We never use mono on the first element. And then the second one is oxygen. So again, it becomes oxide, and there's two of them, and the prefix for 2 is di. So dioxide. Awesome. So sometimes things get kind of crazy. For example, there's another nitrogen compound that's oops, I lost my pencil. N2O5. That 5 is sloppily written. N2O5. I'm going to scroll this up a little bit here, guys. There we go. Oh, we can't see all of our prefixes then. There we go. N2O5. All right. So we've got dinitrogen again. We have oxygen. We have 5 oxygens, so it's got to be oxide. And the prefix for 5 is penta. But I picked this one specifically because we have an element that begins in a vowel, and we have a prefix that ends in a vowel. And so there's a very special thing that we do. Whenever you have a prefix that ends in A or O, you always drop the A or O off the prefix when the element starts with a vowel. Vowels, of course, being A, E, I, or A, E, I, O, U. So oxide starts with a vowel, O, and we have a prefix, 5, penta, that ends with A. So we have to drop that A. So it's not pentaoxide, it's pentoxide. And those are all of the rules really for naming these covalent compounds. Never use mono on the first element. You put the prefix on the beginning of the name for your element. The second element has to end in "ide," and you drop the O or the A if the element starts with a vowel. So let's try going the other way. There just so happens to be a compound whose name is tetraphosphorus hexasulfide. Tetraphosphorus hexasulfide. So first thing we have to do is see, are there prefixes, and if there are prefixes, what are they? So in this first part of the name, tetraphosphorus, I recognize the prefix tetra. Tetra is up here, and it looks like tetra means 4. So that's my first prefix. Now on the second part of the name, hexasulfide, I see another prefix, hexa, and hexa is the prefix for 6. So tetra means 4 and hexa means 6. I have tetraphosphorus. Phosphorus's symbol is P, and it's tetraphosphorus, so P4. The prefix tetra means 4. And then hexasulfide. Now sulfide is not on the periodic table, but remember, what's happening here is we're taking an element and we're changing the end of it to "ide." So sulfide is not on the periodic table, but sulfur is. And so what's happened is we've changed the ending of sulfur to sulfide in this compound, as you're supposed to. So the symbol for sulfur is S, and it's hexasulfide, and hexa up here means 6, so it's S6. And so the formula for tetraphosphorus hexasulfide is P4S6. And that is how you can switch back and forth between the names or the formulas of covalent compounds. If you have any questions about the prefix system, when to drop a vowel, how to make different element names end in "ide," or any part of this naming stuff, always feel free to ask me in class. Thanks for watching.